Hi, welcome to my channel. Um, I'm just we'll just go through a small discussion about how to hyperconverged infrastructure. This just be a very brief video about what HCI is, how it compares with the existing data center architectures, and in the case of a data center evolution, where we are. So this video is going to cover only those aspects, and I'm really excited to talk to you all about hyperconverged infrastructure in this live stream. So before we go get into the details, so I just want to introduce myself. My name is Shrikant Devaneni. I'm an OEM solution architect working in the data center industry for past 20 years. I've been specializing on how different types of server architectures have been implemented in data centers by companies. In my current role, I help customers to select the right product from HP portfolio and implement a solution in the data center for their business. So their success is our success, and we would like to make sure that they adapt the right architecture which will optimize for their business, and that is what is my role is as part of my OEM as a solution architect. So let's go in depth about the past. So what exactly was happening from day one in the server architecture, how the server evolved or the architecture evolved, and where we are right now. So to start with, let's go with the basic server usage. So we do have a compute environment. So this is a story that how an architecture, a simple architecture would be like 20 years back, somewhere in 2000s. If at all somebody is buying the server to run his business or to do any kind of computational activity, this is the basic deployment that he used to perform. We do have this, used to buy a server, and the server usually comes with its own compute environment. The compute usually the CPU, it may be an Intel or AMD. In Olympus, we have the Itanium processors, and there were like the RISC processors, CISC processors, and there are different servers that were manufactured at the time. But eventually, we landed into a Intel x86 and x86 64 architecture. Most of the servers right now are with those processors. So we do usually have a processor and a RAM for any kind of computational activity. For any kind of storage activity where you need to store the data once you are done processing it, or you are going to process it, or in case of you have a cache, you usually have some hard disk. And these hard disks, these are cylindrical hard disks and spinning hard disks that store the data that computation or the application pushes to those disks. Then to communicate to the external world, you have a network interface card or NIC, and these network interface cards usually connect to a switch. So we'll talk about that one later. So the customer, when he is going to buy these servers, he is going to install a Windows or a Linux OS. 20 years back, Windows was more popular. Linux was still catching up to Windows, and he's going to run his own user application. So these user applications can be a database application, a banking application, let me click a DB or a DB Fox, or there were like many old databases that people used to use on Oracle application. Oracle was something that was king of database at that time, and the customers also used to run their own web servers or any other applications that they work with respect to their business. So these applications will perform computational activity, and they will either get data from the external world, do their computation, store it in the disk, or they will get do computation and then store it on the disk and provide to the users when needed. So So basically, whenever a network packet gets in, so it's going to send the data outside to the network switch or receive the data from the network switch. If there is any storage activity, then it's going to write it to the hard disk. So this is the basic server usage of in many most of the data centers a couple of years back. I would say decades back. Now let's move to the next evolution of a server. So then comes the age of virtualization. So people start to see that okay, the server is there's a compute server and we have an operating system and running applications, but it is not utilized to its optimum capacity. So in these scenarios, so what can we do? So then the virtualization is one of the solutions that was provided by VMware, and where you can run multiple operating systems and multiple applications on the same server using the compute capacity to its optimum level. So the server hardware, there's no change in the server hardware, but there's a change in how the operating systems are loaded on the server. So usually we have bunch of VMs. So these VMs will be running on an ESXi or a hypervisor, and all these VMs usually write their data to a VMDK file. A VMDK file is a regular file, which is a virtual media disk file for VMs, where for a VM that is the hard disk. So for it's completely abstract that it doesn't know that it's actually writing to a disk file, not on an actual hard drive. Nick cards, it's still the same capability, but there was in VM there was some kind of we can say virtualization in case of Nick also, like using either as a NAT or a bridged, or you can create an open switch and those kind of, and each VM will get its own IP address, but it passes through the same switch. So, and these VMs usually run the companies or the business applications, and they will send their network packets out via the NIC card, and any kind of storage is written to the VMDK file. And the VMDK is just a regular file for the overall hardware from an ESXi or the hypervisor perspective, and that data is written to the hard disk. So after this, when we started to use the compute environment more optimally or to its maximum capacity, then we thought like, what are the next level of changes or enhancements that we can do this to do this architecture, and then we come up with this traditional data center architecture, which I feel like it has been there in the industry for more than like 10-15 years, and there are still many customers who still use this. Around 50 to 60% of the customers still use this architecture. So even in this scenario, you start with a compute node. It may be a regular server, a DL380, 360, or any other servers from Dell or Supermicro, and it has a fiber channel or a HBA connected to it, and it also has a NIC card. Uh, so as usual, we have the ESXi and hypervisor. We can, or it is running a traditional Windows or a Linux server or a Linux operating system. So mostly to optimize the compute, we use VMs, and in this case, these VMs do have a file system, but there is no storage on this service. In some scenarios, we do keep storage just for the purpose of cache, but you can avoid completely to not have storage or just have the compute in there. And these file system, how this file system is created. So this is how the magic happens here. So the storage is completely located externally on a external storage array. These are called storage enclosures. There are different names they call storage enclosures or JBODs. And these all the storage, all the hard disk are actually in this storage enclosure. And these storage enclosures provide something called as a LUN or a logical in number or a for a fiber channel or be assigned to a fiber channel HBA. And this fiber channel HPA will create a virtualized disk, which for an hardware looks like as if there is an actual storage hard disk on the server, but the storage is completely external to the server. So this storage will have its own file system where you can install your OS, in this case the ESXi hypervisor, and you can create VMs to run your application. VMs and install an operating system and also your applications. But when you write some kind of a data, so the storage is written to a VMDK file virtually, and this storage data is sent to the fiber channel or an HPA, which is in turn sent to the external storage array. When it comes to network, exactly the same way how we saw in the virtualization. So the network is sent to a network switch. So this is how most or like 60% of your current data centers are, and they will eventually they will go out of this because there are things that are better designs that have come up, and one of them is HCI that I want to talk about. Now, there's one more architecture that has been there for some time. It's popular, but it didn't see so much growth compared to the external storage architecture that we spoke in the previous slide. So that is called as a converged infrastructure architecture. So this is not a hyper-converged infrastructure, it's just a converged infrastructure architecture. Don't confuse this with the hyper-converged infrastructure architecture that we are going to discuss. These two are completely different. They just share a part of the name, but they are completely different. So in this case, you have the server and the compute environment, and the compute environment has no storage or no storage on the server. There may be some for cache kind of activity, but mostly it doesn't have any kind of storage on the server. And but it has one specialized card. It's called a converged network adapter. So, so what is this converged network adapter? So let me explain how things work. So in all the things that we saw, there'll be usually two cards, one for a storage, another for a networking part of it. In some cases, the storage is locally on the server, but in case of a traditional architecture, you have a NIC card, and you also have a storage or a HP or a fiber channel card. But in case of CNA, there is one single card. This single CNA card connects to a specialized switch. It's called a converged switch, and the converged switch usually is connected to both a enclosure, storage enclosure, and a network switch. So what is the benefit of this is instead of running two cables like in the previous architecture, one for storage and one for networking, you have one single card and one cable coming out of the server to a converged switch. So this will help us to scale and also has good RAS or the rack capability or rack maintaining kind of feature where I just need to deal with one single wire coming out of the server, not multiple things, just a single cable and also a power cable. That's all that I need to set up this server. So when the application is runs on the servers, so they usually send the storage packets and the networking packet to the converge switch. The converge switch is responsible for splitting those data and sending the respective packets to an enclosure or to a network switch. So this is how a converged infrastructure works. Um, and there are customers who are using this. There are architectures by other vendors who use similar architecture, and it's also good for a server because I don't need to worry about so much cable management, and it's very simple to maintain. But it also comes with its own drawbacks. Like I need a specialized converged switches and network adapters that also need to be maintained on the server instead of a regular top of the rack switch or an enclosure. So, and also the convert switch becomes a bottleneck in some cases. Now let's go to talk about HCI. So we have gone through the evolution of a data center from a basic server to the virtualization, then a external storage and the NIC cards, and then you have the converged network adapters. Now, when it comes to all these architectures, there are three variables that we always need to worry about. The three variables are you have the compute, you have the storage, and you have the networking. So, if at all there are a lot of solution architects, or you aspire to be a solution architect, this is one thing that I would definitely ask whenever you're talking to a customer. What are these three variable requirements for their business? So, if a customer is saying that I'm very much interested in compute, let's say that he's running some kind of a AI workload, or he's doing some kind of encoding, data encoding or video encoding. So the compute is the most concerning part over there. So you will be putting in more better CPUs or specialized CPUs which have those features in them, the codecs in them, or you'll have GPUs which will help in this AI computation. If the customer's need is storage, then you will think about how better you can optimize the storage uh, for storing the data and also for redundancy. Also, encryption is the data going to be encrypted in REST, how the data is encrypted in motion, all of the scenarios. If he's a networking person, then you think about better NIC cards. So there are some customers who usually are worried about the packet sniffing and finding out like what's going on. There are some network security customers, so you worry about the NIC cards. So the basic, as I mentioned, the basic things are I just compute, storage, and networking. These are the three common parameters that we have seen in all our architectures that we have discussed until now. How optimized, how centrally I can manage all of these three. In all the other architectures that we have seen, there's a different administrator for each of this. There's a server administrator, there's an enclosure administrator, there's a networking administrator. How better can I manage this in a single pane of glass, in a single window where I don't need to worry about having different administrators for all of this? So this is where the HCI comes into picture. The HCI brain or the hyperconverged software, the infrastructure software that will help us to manage all of these three parameters of a data center optimally. And it actually talks to each one of them. It has a features of virtualization and doing redundancy and all these things at one single location or one single entity is going to perform that. It also helps you to combine your resources. Until now, we just went to see servers and the external enclosure. How can I combine all this and use them optimally? And that is where HCI comes into picture. Let's go in detail about these things in further slides, but please keep this in mind. This is the most important stuff. These three parameters is very important to the basic fundamental building blocks of any data center. Now, in case of a simple definition, I would say hyperconverged infrastructure is a software-defined orchestration that virtualizes servers, storage, and networking. So virtualization is the key in a hyperconverged infrastructure. How best you can segment out each of these resources and provide to the users, and at the same time maintaining other factors like security, redundancy, and optimization of each of these resources. Let's go through some of the key features of HCI. So all HCS solutions work on virtualization. So as I mentioned, how can you segment out these individual pieces? And what is a best way to do that is all that hyperconverged infrastructure focuses on. And many of these HCI solutions are better at some of them, They are some of them are good and all of them. So and I'll go through the differences and how these things work together. So there's always a centralized management, a single UI. It is a single UI where you can manage all of them: the servers, the storage, the networking, and also the security aspect of all these things. It's linearly scaling. So let me go back to some couple of slides. In the case of a converged network adapter, let's say that you have a data center which this architecture, and you want to you want to have more service because you feel like you have more some computational or new application that you want to deploy. And when that happens, you are going to add a new server. You're going to have a new CNA, and that connects to the converge switch, and you'll have the storage and everything. So you have an opportunity to independently increase the capacity of either the compute, the storage, or the networking. So if you want more servers, add more servers. If you want more storage, add more enclosures and more disks. If you want more networking, add more switches and connect to them. So the benefit of converged infrastructure, you can independently scale each one of them. But there's also a drawback. Let's say you added more service and for some reason your business went down and you have to reduce the service and you cannot use them. So you have to either sell them and or you don't know when the capacity increases or decreases. But when you linearly scale all of them, the story is a little bit different. And if your business goes down, you have to reduce the hardware that you bought for those applications. So there are scenarios where you maybe have less hardware sometimes in case of independent scaling, but there are scenarios where you will have more hardware that you don't need, but you just have to keep it because you bought those hardware. Let's go back. So in case of a HCI, the scaling is very linear. So if you're adding a server, if you're adding a node to a HCI, you're going to add all three components. So in most cases, I will say you're going to definitely add the compute and storage. And you'll also have the NIC cards that are needed for that server. So there's a linear scaling when it comes to a converged adapter. It's independently scaled on compute, storage, networking. Here you don't have that flexibility. Reporting and analytics. This is so you can actually see the complete picture of all the servers on your HCI solution, where you can report them. So how much capacity is being used, what is the security, what kind of data are getting into the architect, getting into the servers, VMs, and you can centrally do all kind of reporting in case of HCI. You can also have multi-site redundancy capability in case of HCI. So you can have two set of nodes or clusters, and when you can also replicate the data easily and make sure that the other site is up and running in case of a failure on the current data center. We also have an hybrid or a multi-cloud infrastructure. When I mean to say hybrid is like you want to have a public and a private cloud environment integration, and many of the HCI solutions provide that option. And you'll also have multi-cloud where you want to select like a private cloud, a private HCI deployment at the same time. You want to connect to Azure for some kind of features, and you want to connect to AWS for some kind of features or services. You can actually do that with HCI. And many of these HCIs are evolving to provide those kind of integration between multiple public and private clouds. So when it comes to HCI, there are two basic architectures are out there right now with from different vendors, and they all differ on mainly the storage virtualization. So what are the two architectures are? There's the virtual storage appliances, and then you have the kernel integrated type of architecture. So let's go in detail about both of these architectures, but mostly if the virtual VSA based appliance architectures is most prevalent in the market. Kernel integrated are provided by some customers, mostly VMware, vSan, uh, but we'll go through in detail about each one of them. Storage appliance. So uh, the virtual storage appliance architecture is let me go through each one of these subcomponents and you can understand this. So the orange box that you see is an individual server. It may be a HP server, Dell or Supermicro server, and they usually run in hypervisor. It can be ESXi, a VMware-based hypervisor, or a KVM-based hypervisor, or a kernel virtual machine-based hypervisor by DNS, which comes with any of your Linux distros or Linux offerings. So the server also has its own storage. These are individual disks. They can be hard disks, SSDs, or NVMe drives, and they all are part of a cluster. So we have three servers here. So the complete storage on three servers are shared by a single, shown to the users as a single pool of data and a single namespace. So in this scenario, we do still have VMs. So this is how we are going to virtualize uh, the compute environment, the compute variable that I spoke about in a couple of slides back. So you have VMs and they will be running their own applications. And there is a specialized VM. It's called a virtual storage appliance, and it usually sits in all of these servers, and these VSAs communicate with each other. So they communicate to form a cluster of three. In this case, in this example that I'm saying, there's a three-node cluster of HCI solution. And whenever a VM is created, a virtualized storage pool of data is allocated, usually a VMDK file. And this storage pool of data is actually stored down to the server's hard disk. But VSA has intelligence to store the same data on multiple servers. So let's say there's a VM and you have a database engine running on this VM. And if that database engine is write some kind of data, it actually goes to the VMDK file. The VMDK file in turn will be written if the VSA intercepts the data. Okay, there was a data change in the virtual environment, and it takes a copy of the data, stores into the server. At the same time, it contacts the other VSA and stores another copy in another server. So you have the same copy of data on two servers, and based on the redundancy level that you set on any of this HCI solution, you can also have multiple copies of the same data. Even one of the node is goes down, you still have the data available on other nodes in the same cluster. When it comes to virtualization, they usually all of these VSAs usually create virtual switches on the hypervisor, and the VMs will be assigned their own networking IP addresses or individual private IP addresses. You can also microsegment. Let's say that you want to allocate VM1, VM2, and VM3 on the third, VM2 on the third node as for HR, or you want to do VM1 and VM3 and VM1 and node 2 for accounting. So you can actually microsegment them and also provide IP addresses. All these things will be managed by the VSA agent that is running, or it is actually a VM that's running on each of the individual nodes. And this is how a virtual storage appliance uh, kind of architecture HCI solution works. So you are able to virtualize the compute using VMs. You are able to virtualize the storage because the complete pool of data is shared across all the nodes. Your data is replicated among multiple nodes, uh, i- and that is how things were you virtualize it. At the same time, you're also virtualizing the networking part. So each NIC card that is on the server, you are able to provide IP addresses. At the same time, microsegment VMs on multiple nodes into each of their own groups for reporting or also or maintaining them for individual accounts. And you can provide the different set of IP address or subnet of IP addresses for each one of them. So this is how a virtual storage appliance works. Now let's go to the kernel storage virtualization. In case of kernel storage virtualization, we don't have a BSA, but all the the IOP interception and duplicating of data is usually managed by the hypervisor itself. In this case, the VMware ESXi. So we still have the same principle. You have compute virtualization using VMs. You have storage virtualization with a shared storage pool. You have the networking virtualization with the network switches or software-based open switches on each individual node and connecting to the top of the rack switches. So, so this is the difference between both of these architectures. And most of the external vendors, they usually fall under the virtual storage appliances. So we'll go through those details. Now, when it comes to HCI, these are the things that it's specialization. I'll go through each of those three variables that we mentioned when it comes to compute. So it's in case of appliance based and hyperconverged solution or software only solution. So what does this mean is there are customers or there are vendors who create who come up with a product where they have the server and also the software pre-installed on it. And there are customers who are vendors, HCI vendors, who say, please go and buy a server from any of these certified vendors, it may be HP, Dell, Lenovo, or Supermicro. We will provide the solution. So in appliance based, you will be provided with the server, including the software. Whereas in a software based solution, you are free to buy any type of service in the market that is already certified by that company. So if a software only solutions are opted, then you have an option to choose which is the best product that you it's in the market and also the price that you want. And most of these software based solutions they provide kind of a HCL or a hardware confinement list or a configuration list saying that we have approved these servers to be used with this HCL solution or HCL software. So users will be able to create VM with desired storage, as I mentioned, and you can also configure the networking. You can also set VM management policies, like as I mentioned, you can group them for different business segments or different types of applications that you want to run. So most of the HCI solutions support VMware ESXi. Some provide their own hypervisor. In the specialization, I would say Nutanix. They have their own KVM-based hypervisor called HV. It also helps us because based on the licensing that you want to buy. So VMware ESXi has its own licensing, and some of them provide free hypervisors, KVM based, which don't require any kind of licensing, where the customers can save money. So it also can built in microservice applications like Kubernetes also. In case of if you want to deploy a Kubernetes application or a Kubernetes VM over there, it can be easily deployed with many of these offerings that HCI solutions are coming up right now, and it can be easily integrated with any of the external public cloud offerings of Kubernetes. When it comes to storage, so storage is directly connected to the nodes, as I mentioned. When you compare to a external storage or a CNA based storage, these storage are physically located on the server and they are shared across all the nodes in the cluster. And most HCA support hybrid and flash. So when it's a hybrid, so you have the SSDs as well as the HDDs on the system. They're hybrid. So usually they use SSDs for cache kind of environment, and HDD is for storing cold data or a data that is not frequently used by the VM. It is pushed down to the cold storage, that is the hard disk, um, which are not so efficient when compared to the SSDs. All storage in the cluster is available. So as I mentioned, the overall storage pool that you will see in either the virtual storage appliances or the kernel storage appliances. Uh, Most of them support deduplication and compression. So when the data is written to the hard disk, it makes sure that it doesn't uh, make multiple copies of the same data. Let's say that you have two VMs, and these VMs are just a clone of each other. Their VMDK file will be the same in the hard disk, and their blocks of data, until unless there is a change in one of the VMDK files, the same data will be referred for both of the VMs. So that's a deduplication. So you store a similar block of data. If there are multiple block of data and they are all exactly the same, you just save a single copy onto the hard disk. At the same time, this data is also compressed. So you'll also save space when you're storing this kind of data. SA solution will also support RAID and RAIN. So RAID, you also is an array of independent disks, and RAIN is stand for redundant array of independent nodes. So as I mentioned, in case of HCI, whenever a data is written down to the hard disk, the same copy is also available in another node on the same cluster. So even one of the node goes down, you still have a copy available in another node. And you can also set the redundancy of the fault tolerance level. If you want to have 3 or more copies, you can also keep that on multiple nodes. And if there's a node failure, you still have the data. Multi-site data backup. So you can have a cluster in your data center. You can also have a cluster. Let's say you have two data centers in east and the west of the United States. You can have multi-site data backup. So you can have the east side data to be backed up in west. Whenever there is a failure or any kind of site is down because of the environment, hurricanes or any kind of things, you can immediately bring up the data center on the west, and you have exact copy. So you also have erasure coding. So erasure coding comes into a picture where you want to save data. When you're writing this data into multiple nodes, you want to have the same level of fault tolerance, but at the same time you want to reduce the data that you write using parity. Uh, this is an independent topic that we can go really deep. It's also something similar to RAID where you have multiple parity blocks set. So if you have a block that you want to write, and you have another block of B, so you can actually write the block A, block B, and also the parity of block A and B in another node. So if E goes down, you still have the parity block and the block B to get back A. At the same time, if parity block is gone, you have A and B to get back the. So at any moment, you still have the same level of redundancy, but you can also store less amount of data on the storage. So you can Google out on those topics, and it's a very good topic that you guys can learn about. So when it comes to networking, as I mentioned, you can segment out, you can make different VMs in a subnet using their management window. And you can also make sure that those segments don't talk to each other for security purposes. Service insertions, so you can also um, include service insertions in any of these segments, saying that any data that goes out of these three VMs, make sure they are under a firewall or a load balancer, and also you can manage the traffic or look into the traffic, what kind of data is going out of these VMs. So they recommend policies on the physical network. So when it comes to network setup, they usually have multiple nodes in a cluster, and you have the top of the rack switches. So how these are connected, they usually have some restrictions. They want to make sure that no data from one node to another node, if at all there's backing up the data, should not go more than two hops in the top of the rack switch. So it should go to the top of the rack switch, to another top of the rack switch, and down to the node. So this kind of setup will make sure that you have the efficient HCI configurations and you don't lose the data. And because these things do deduplication and for redundancy, it copies the data from one server to the other, and it has to do it at a very fast rate. It also enables API-based notification for third party. So if there's a VM that dies or it fails, so you can immediately get a notification saying that your VM has is down. Do you want to start a VM immediately with the data that we already have in the redundant node? So these kind of lifecycle events you can actually configure in API-based ones, and also the software-defined networking, the SDN. So this is a topic on it itself, which can make a couple of more slides. But in case of a different networking, you actually define provide intelligence to your networking so that the packets are transferred from point A to point B as fast as possible with less hops. So whenever it goes to a gateway, you make sure that you find the optimal route as soon as possible using software-defined networking, where you tell them, okay, please send this packet to this gateway so that it goes to the fastest route to reach B. So this kind of software-defined networking also can be defined in HCI. So when it comes to HCI, there are a lot of vendors out there. A lot of them, there are a lot of players, and there are some very important and well-known players. So the one that we are talking about is the Gartner's HCI Magic Quadrant, and it has been evaluating these HCI offerings in the vendors and how they scale with respect to their vision, ability to execute, and where the challenges and how they are performing in the market. So Nutanix is at the top. So Nutanix is we HP also partners with Nutanix, and we have the highest number of Nutanix DX family-based offerings that we offer to the customers. And we have from higher density to high performance. So you can choose what kind of service that you want to deploy. Uh, and when it comes to the kernel storage based architecture HCI solution, you have the VMware vSan. And then you also have another offering from HP called Simplivity, which is also an HCI solution based on VSA kind of an architecture. So, if you want to check out any of these HCI solutions for your business, please make sure to contact me if you want to know more details about it. I can definitely help you with respect to how these things work together, and we can come with a better solution implementing any of these Nutanix because HP works with Nutanix, VMware, as well as we have our own HCI solution called Simplivity. So please feel free to contact me. That's it from my side. Thank you for going through these slides and knowing just a little bit of knowledge about hyperconverged infrastructure. And it was a very delight to have you guys here and talk about these things. My details can be found on LinkedIn, or if you can email me, and I can definitely answer any of these questions to you guys. Thank you very much.